Hi everyone, my name is Viktor Leijon. Today we're going to talk about Netsim. If you worked with NSO for a while, I'm sure you've already seen it. It turns up in all of our early tutorials and examples as a widely used tool. But you may never have thought more deeply about it. You may never have dug into it. Today we're going to talk about Netsim Unboxed and talk a little bit about what is below the surface of Netsim. Hopefully, we'll get a few good ideas and techniques on how to use it more efficiently in the future. Let us start by giving a quick overview of Netsim, what it is, and some basic usage. So, when you're building an NSO application, it's very important to test it. And there are many different ways to test NSO and test your service, your application, your deployment, and your methods. The gold standard is to use real devices. And everyone should have a test lab of real devices because everyone has a test network. And some people have a separate network for production. And it's very important that you try at least a little bit on real devices. But as we all know, real devices are pretty expensive. And for that reason, we need cheaper ways of testing. One way to do it is to use virtual devices. You can use something like Cisco modeling labs to model your devices using virtual machines and spin up an environment. These virtual devices are fairly expressive. They can do a little bit of traffic plane, a little control plane, but even that comes with a cost. So you might want to do something even simpler. So there are two ways of doing it in NSO without involving real devices. One is to use SAP Unlocked to lock a device. The other one is to use Netsim. Now, Netsim, as you know, is the main topic today. But I want to take one moment to talk about SAP Unlocked because I think that is a technique that is easily missed. SAP Unlocked is essentially just taking a device and setting the admin state to SAP Unlocked. This means that the device is locked southbound. It will never try to touch the actual device, but you can still write config to the config tree. So this means you can do all of the inside NSO tests. You can make sure your service doesn't crash, it gives the correct output and stuff like that. It's very fast and efficient, and the device doesn't even have to exist. Of course, since we never touch the device, we will not exercise the device, we will not exercise the NED, right? But if you want to look at something that's inside of NSO, you can use the SAP Unlock device. Now, on to talking about Netsim. What is Netsim? Well, it's an abbreviation of Network Simulator. And Netsim is not a real device. It's important to mention this, right? There is no control plane. There is no traffic plane. There is only the management plane. All you can do is talk to it over the management interface. Essentially, what we're doing is that we run the NED in reverse. This works very well for NetConf and for Yang, using the same Yang model as we use on our NetConf server, on our NetConf client. So the NSO server runs the NetConf client, while Netsim runs the NetConf server. The other protocol that works really well for is the CLI. There's sort of a funny backstory here. About 10-ish years ago, the NED framework sort of arose from this realization that a parser and a generator for a language are two sides of the same coin. So we can both generate the CLI. If you use NSO, you have seen the CLI, right? You can do show running and see the config generated in a format. And you can enter commands, so you can also parse input. And this is the basis of the CLI nets. They're driven through these annotations on the YAG file. And since we have these annotations, we can run a netsim based on the net. If you have a net that's not netconf or CLI, then you have more limited possibilities. Sometimes you can run the NED as sort of a NetConf NED for Netsim purposes. But generally, this is the most efficient if your NED is NetConf or CLI. By default, it works really well for configuration, but you can do more, and that's going to be one of the main topics in a little bit. Under the hood, Netsim uses confd as the vehicle. Confd is a little bit like NSO's little brother. It can do a lot of the things that NSO does, and it's meant to be used as a device agent. It's meant to run on a router or a switch and act as a management agent. And of course, that means that it's very good at simulating a management agent. And we'll see a little bit about how that works out in a few minutes. By default, we can use the NCS Netsim command to control Netsim. You can do other things as well, but that's sort of top level command. Here are a few basic commands. You use the create network subcommand to create your initial network of Netsim agents. And you use add to network to add additional elements. You can list instances, start, stop. You can start a CLI against an instance, and you can use SS XML init to get a piece of initialization information for your Netsim devices. So with this intro out of the way, let us jump straight into a little bit of a basic demo of Netsim and what it does. So let us look in the environment. So I have a number of Netsim instances. I have 3 iOS devices and 2 router devices. This is a small NetConf NED that we'll get back to in a few minutes. I can use a few of the commands, right? I can check if it is alive, and they are all alive. And what does it do? Well, as I said, this is based on confd, and if we look at the processes running here, right, there is a confd running for each Netsim instance. And of course, we have a help command if you want to know more about what you can do with Netsim, and there's a man page for all that. I want to show NSS XML init because this is an XML format of the device configuration you load into NSO. So what I like to do, I like to generate like this, go into NSO, load merge init.xml like this. Now I had already had them loaded, and then show devices list, and you don't need to remember to do a sync from and things like that. So this is a small NSO with a little bit of Netsim instances. So let us start in a separate shell, a CLI for iOS 0. So this is the first iOS instance. I can do show run and see just the configuration that's available in my Netsim instance. So what happens here? If I go into NSO and I do devices, device, iOS 0 config hostname, tree, like this. So this would push a single command down to the Netsim. And today, we're going to use very simple configuration. We're going to use very simple setups just to make this move along smoothly. But of course, the same thing works for much larger configs. Your time to do more typing. So do commit here. The device will be updated. And if I go to my Netsim, I'll see this message. Commit crawl by admin using by SSH using CLI. So if I show running hostname, it has now been updated. Now, one of the most basic things I can do with Netsim is to try and check the auto-sync behavior. I can go into config mode of my simulated device. I can do hostname another, right? And commit this. Note that NSO doesn't notice this. NSO doesn't know what's going on with the Netsim by default. Just like NSO by default doesn't know what's going on the device. So what we can do, we can run a check sync on the device like this and get an error. we're told that we're out of sync with our Netsim. But if we run a compare config, we can see, of course, that this is the change that we didn't anticipate. And I can do a sync from dry run out format CLI, see, and see sort of what the difference would be if I did a sync from. In this case, I'm just going to do a sync to. NSO is the master here, and oops, and the host name is now been restored to what it was on the NSO side. And in this Netsim, I don't have a full device simulation, but I have access to a few commands. I can do show version, for instance. The Netsim. And this shows up if you do show devices, device platform. We'll see that we get the Netsim model out of all of these devices. So that is sort of the basic introduction to this. Let us go back to our slides for a moment and learn a little bit more. So let us dig deeper into the CLI in particular, right? And I want to take a detour to talk about something called Netsim Control Panel. Netsim Control Panel is a nice tool that Ulrich made a few years ago that's part of something called NSO Scenario Explorer. So if you want to understand more about how NSO works towards devices with commit queues and error handling, all of that, I recommend that. It was a topic on the previous dev days. Today, we're just going to talk about the control panel. It gives you basic transactional control over Netsim. It lets you count the number of transactions, delay them, add manual acceptance, just so you can absorb the timing and understand the behavior of NSO in various scenarios for the devices, right? What will NSO do if there is an error on the device? And using Netsim control panel, you can control all of this. Okay, so what is Netsim? Netsim is a directory with a number of files. You can enter an environment and become part of it by sourcing the N script. I like to use the rc file command on bash because I can't unsource a file. But if I use a bash shell, I can just exit my subshell when I want to move on to another place. And in there are a number of scripts, such as the start script and the stop script, that is triggered every time you start or stop Netsim. And once you're inside of this environment, you can use confd commands. And as I said, confd and NSO are very close relatives. So you have a confd load command and an NCS load command, a confd cmd and an NCS cmd, a confd CLI and an NCS CLI, and they work in very, very similar ways. So a lot of the tools that you know from NSO will just apply directly to Netsim. And of course, you can modify Netsim behaviors. Each NED contains a Netsim directory that controls how Netsim operates. It has the same model as the NED, but it also has CLI spec files that control how the CLI behaves. It has a number of shell scripts and other tools. You can modify and rebuild this to suit your own needs to customize. It isn't automatically copied to existing NetSims, so you might have to manually copy it over or recreate your NetSims to get any updated behavior. So you might never have heard about CLI spec before, but actually it works just as well in NSO as it does on confd and Netsim. It allows you, as the name sort of hints at, right, to modify the CLI and specify the CLI behavior. To the right-hand side, you see a little snippet that mounts the show version command, saying that there's a command version, it is a sub-command to mount, with a bit of info information and telling us that when I run show version, you should execute the show version shell script in the same directory as the Netsim. And you compile this CLI file into a CCL file, usually one for C style and one for J style. And you can use this in NSO to make your NSO CLI behave in advanced ways. And you can read man CLI spec for more documentation, but it's very heavily used in conf and in Netsim. And that brings us to live status data. There are two kinds of live status. There is a show, where you show a live status piece of data from NSO, and there is actions, where you call an action such as ping in this example on the device. On CLI devices, live status parses CLI commands. And on NETCONF devices, it reads directly from the database. For actions, of course, on NETCONF, it will trigger a remote procedure called RPC or an action running on the device. But for show commands, it just does a query. It issues a NETCONF get command towards the device. So let us move into our second demo. We're going to look at Netsim control panel, and we're going to look at extending Netsim for CLI NEDs a little bit. Let us start with the Netsim control panel. Let us take a clean environment. So on a Netsim control panel like this, it shows us a small ASCII UI. We have a help pressing H that shows us which commands are available. So let us start by increasing the delay on iOS 1 to 5 seconds. Now, if I go into NSO, setting the host name to DevDays 2024, and this would update the device name on the iOS device. Let us commit this, and notice that it now becomes slow. And if we look at the Netsim control panel, we can see that we have a transaction that's now gone. This is our first transaction since we started the control panel. And if I do this again, it will turn up again and then go away after 5 seconds. So this is really nice, right? It lets you control the timing behavior on a device, because generally Netsim is much faster than real devices. So let us look at the other very interesting feature, and that is manual acceptance. We press the M key, and it is now in accept mode. So if I try one more commit, nothing happens. And what happens here is that the device goes into a hold mode, waiting for me to either accept or reject the transaction. I press accept and go back, and the commit has now gone through. But of course, I didn't have to accept it. So I can do this again. I can go back, and I can press R for reject. And what happens is that I get an error. This simulates an external error in the NED or a problem with the device or something like that. And similarly, from the control panel, you can start or stop a device. In this case, the IOC went down. Start it again, like this. Oops. And this lets me simulate various down behaviors and stuff for devices. Oh, that is back up again. So that's a Netsim control panel. Very, very useful tool for exploring timing behaviors and stuff. Okay, so when we run NSS Netsim list, we can see that we also get a directory for each of these nets. So let us go into the iOS0 directory, like this, and look what we have in here. We have a number of different files. We have some FXS files, we have the CCL files I mentioned, We have a number of shell scripts. We have the audit log. So I can look at the audit log, right? tailf audit log like this, and go into NSO, and I can change the host name again. And what happens when I commit this is that, oh, sorry, I need a new value. When I commit this, it will go out and run a number of different commands on the Netsim environment. And I can use the audit log here to understand that. And the other thing that's worth mentioning is that I can go into the environment like this. And if we look at end.sh, we can see this sets a number of interesting environment variables that are needed both for Netsim and for me, that tells us where to find all the commands and which ports to use, right? And this means that if we run the Ntsims, for instance, the conf CLI will connect us to the right version of the simulator. And if I look at CLI.sh, that's exactly what it does. It sources the environment and starts a CLI by default with the J mode. Now, there's a lot of stuff I can do here. We can use the conf load command, for instance. So this saves the configuration in C style. I can take the data in pretty XML format. I can save it to a file, and I can edit that file and update the configuration I want. So let's say that I want to change an IP address, for instance, like this. I can change this to 1, and I can load it back, load, merge, format, print XML, data.xml. And this changes the data, right? So I can bulk load data. If I have a real network, I can take data from real devices and save them in a repository and populate or pre-populate my Netsim instances with real data. So similarly, I can use a conf cmd and all of those commands, right? Okay, the other thing, if you look in the CDB directory, is that a database for the Netsim will turn up inside the CDB directory. And you see there are 2 XML files here. These XML files are init files. Anytime that Netsim starts, without a database, but with XML files in the CDB directory, it will take those XML files as init data and load them into the database. And NSO actually works the same way. If you put XML files into the NCS CDB directory, before you've ever started NSO will use those as init data. And that actually happens, for instance, to initialize the AAA config in NSO. So let's take a look at how this looks inside the NED. So we said there's a Netsim directory inside each NED. In this case, it's a Cisco IO CLI NED. You can see here, for instance, that here is that CLI file with all of these setups for ARP and LDP and showing a verf, right? So when we want to run operational commands, this is actually how that works. So if we take that as an example, right, in NSO, we can do devices, device, IO0, live status, exec, ping, and this will simulate a ping. What it actually does, if we look at ping.sh, is it runs this little shell script. It looks at a few things, right? That if your IP address begins with 254, your ping will always fail. Like this. And I can modify this. Here I've set in so that 2 last ones will succeed, But I can make them all fail just by editing this. I can use this to simulate various behaviors to make some things fail and some succeed. And the other thing, right, we talked about two kinds of operational data, about actions and data. So let's show data. So this is reading live status data. Show devices, device, iOS 0, live status ARP. And there is no ARP data available. Why is that? Well, if you look at our show ARP script here, that becomes very apparent. There is no data at all in the show ARP script. But of course, once again, if you have a real device, you can take the output of a show ARP and paste it in here. I prepared a little bit. So I have a show ARP script ready. And if we look at this, I've done a few different things. I've pasted the output from a real device, an old real device, so that it parses properly. And I've added a bit of randomization. Every time I run this script, I will get a slightly different IP address. So if I run this now from the NSO side, I will get some data. What is worth noting here is that in NSO, we actually have a parser. Data that's part of live status is parsed into a structure that's very easy to access and modify and play with from a Python. The other alternative, of course, is to execute. So you can execute the show command or show ARP instead. And that also works. But if you look at XML here, all you get is a single string that you have to parse yourself. Now, in many cases, this might be more flexible. Our parse are far from perfect and doesn't have all the commands. But this has a lot of nice advantages. You can see here how the IP address is randomized on each show that we do. So that's sort of some of the possibilities available for you with a CLI NED. Now, let us go back to the presentation for a little bit and talk about NETCONF. Now, NETCONF NEDs are not as common as the CLI NEDs are, but they're still very important. And I do want to talk about a few different aspects of them. So as we said, NETCONF NEDs, or actually all Netsims, works like a mini NSO. It would be more fair to say that NSO works as a big confd because confd was there first. And this is true both for NetConf Netsims and CLI Netsims, that they can be scripted using Python in the same way that NSO can. And for NetConf Nets, operational data is generally stored in CDB instead of generated using a show command. And this means you can use confd load on operational data. And you can modify and observe the operational data using Python code. You can react to changes using Python subscribers. You can send notifications and take actions when your data changes. A lot of this is possible for the CLI nets as well, but you can't modify the operational data in the same direct way. So this makes for a good demo environment. So we'll use the router NED. The router NED is an example NED that's delivered with NSO. It's a small toy of a router with NetConf. You can see here, we'll talk about the interfaces subtree. There are two parts. There's a read-write part that is the configuration, and there's a read-only part, is the operation data. So for each interface, there is a status container with some speeds, some link status, etc. So with that little bit of preamble, let's jump straight into our third little demo, extending Netsims for NetConf NEDs. Okay, let us get out of the Netsim of the iOS. And here's the advantage of using the bash command. I can just exit out of the shell and start over. I go into router 0, and I can do a similar thing. I can source the env file. The env file here looks very similar. It is the exact same structure, only different values. And slightly fewer scripts available here. So let us take a look at this device from NSO. So if I do device router 0, config, sys interfaces, let's talk about ethos 0. Let's set the description to dev days 2023. If we do commit dry run also native here, you guys see the NetConf payload. You guys see an edit config message telling us a little bit about how we want to change things and what we want to change. I can commit this just the same as I can for the CLI nav. If we look here, we run conf to CLI minus u admin. Like this, it looks the exact same way, right? Okay, so what I can do is that I can look at the operational data in the NetConf environment. As I said, this is stored in CDB in the client. So if I do show devices, device router 0, live status, sys interfaces, interface status, I see no status information at all right now. And similarly, if I in the CLI here do show sys interfaces interface, I see there is currently no operational data available. But as I mentioned to you, in the NetConf case, I can use conf_load. It happens to be, let's take a look at the NED. It happens to be that the NED here contains a few different things. In particular, it contains a number of examples of oper data. So let us take a look at example 0. It's a simple piece of counters for the different interfaces, both for ETH0 and ETH1. And we can load that into our conf. So what we do is conf_load, load merge operational data. Oops, too high up. So let us just load merge this data, and it's now part of the CDB. So if we go back into the CLI and take a look, the counters are now there. And similar, of course, if I go to NSO, they're also there. Now, I can also use conf_cmd to modify that. Conf_cmd and the corresponding NCS CMD is a very convenient way of essentially running the APIs from the command line. And one thing that's annoying a lot when you develop NSO is you need to remember the paths. But we have some convenience functions, so we can just extract the key paths from conf. So let's say that I want to change the status of the link. I can run conf_cmd operational command set the link to down. We'll go back to the CLI. The state is now down on ETH0. And similar in NSO, the link is now down. And this is pretty useful if you want to trigger an error or if you want to somehow summarize data, right? This is kind of helpful in a script, but even more helpful is being able to do this in a programmatic way. And as I said, conf behaves a lot like NSO, which means that we can use the Python scripting. So I prepared a little bit, and I created a script called the incrementer. So what does the incrementer do? Well, it imports NCS, but it grabs this conf, the IPC port from the environment and stores it so it can connect to the right conf environment or the right Netsim environment. And what it does is that while true, so forever, every 5 seconds, I will start a new write transaction towards the operational data. I'll go through all the interfaces and increment some of the counters, the transmit byte and the receive byte. So let's take a look at this. So if I run the incrementer, it increments the count on ETH0 and ETH1 a little bit. I can go back to NSO and notice that my counters have started increasing. I go back here and look and see that it increased a few more times, right? And what I can do is I go back here and see how they just keep increasing. So what I've done now in a very primitive way is I've created an environment where counters keep going up. And I can, of course, make this much more complex and make it simulate a real environment where counters keep going up. And if I have something like reactive fast map, or if I have some kind of health check, right, this can give me various test cases for that and help me understand how they develop. But what if I want to have a behavior? Well, as I said, we can use a subscriber. Now, in NSO, we generally want to prefer kickers to subscribers because of concurrency and things like that. But that doesn't matter as much for Netsim. So let us look at a small subscriber. This looks very similar to the incrementer case. I import NSO, I grab the right port, I start creating a subscriber. I create an iterator that stores the key to every interface and then moves on. And then once I've seen all changes, I start a write transaction and I increment the received bytes counters for all changed interfaces by 10. So I can run my subscriber. Now, my counters have stopped incrementing. They no longer increment automatically because I stopped my incrementing job. But what I can do, I can change my description to new disk, and I can commit it. And what happens is that the counter goes up 10 steps, just as expected. And you can see here that my subscriber noticed this change and did this incrementation. This allows me to implement very powerful reactions and behaviors in Netsim, where we can react to the changes in the network. And I can send a subscription, I can kill the conf if I want, I can do whatever I want to sort of simulate the behavior I need for my automation. So this makes Netsim a very, very powerful environment. Okay, let us try and wrap this up a little bit. What have I talked about today? I've talked about how flexible Netsim is, how similar it is to a stripped down NSO, or how similar NSO is to a very bulked up Netsim. Now you can mock behaviors in different ways. You can use conf.cmd, conf.load, or Python. You can use the shell script extensions to make the behavior behave in various ways for the CLI net. And you can use CLI spec to extend this even further. There are many exciting ways to test your code. I hope you've learned a few things today, and I hope that you will explore Netsim and the possibilities that it gives you. Finally, I want to end on a few resources. These are the links to Cisco Modeling Lab and the Scenario Explorer, both the source code and the presentation from the previous developer days, which I really recommend if you find that tool fascinating. Thank you very much, and I hope you have a good day.